somewhere beyond the glare of our sun, across 120 light-years of emptiness, a strange world orbits a faint red star. Thick clouds blanket its skies, dark oceans may stretch far below, and for the first time a whisper has reached us. A chemical signature so delicate, so alien, that it could only mean one thing. Life may have left its mark on this distant world. This is K2-18b, and its secrets might change everything we know. But what exactly did we find hidden inside its atmosphere? And how close are we to confirming a second cradle of life beyond Earth? In September 2023, the James Webb Space Telescope turned its golden eye toward K2-18b. Using infrared light, it scanned the planet's atmosphere as it passed in front of its star, a technique called transmission spectroscopy. What it revealed stunned astronomers around the world. Webb detected strong signals of methane and carbon dioxide, both classic indicators of a hydrogen-rich atmosphere. But there was something even more extraordinary. Hints of a molecule called dimethyl sulfide, or DMS, began to emerge from the data. On Earth, DMS is produced almost exclusively by living organisms, especially by tiny plankton drifting through our oceans. No volcano, no lightning storm, no non-biological chemistry we know of produces DMS naturally at detectable levels. If this detection holds true, it would mark the first time humanity has sensed a possible biosignature on another world. But what makes DMS so unique? And why would its presence on a distant exoplanet be so groundbreaking? Dimethyl sulfide is a simple molecule, but its origins are anything but ordinary. On Earth, it is created by living systems, primarily by marine phytoplankton, those microscopic life forms that form the base of the oceanic food chain. When plankton die, they release DMS into the atmosphere, where it influences everything from cloud formation to Earth's climate. What's critical is that DMS doesn't emerge easily through geological processes. Unlike methane, which can bubble up from the depths of barren planets, DMS is an unmistakable breath of life. That's why the faint hint of DMS on K2-18b is causing such a stir. If this signal proves real, it would suggest not just an active atmosphere, but an active biosphere. Oceans teeming with life, however alien it might be. But caution tempers excitement. At 120 light-years away, the data is faint, stretched thin across the void, and Webb's instruments, powerful as they are, can only see whispers. We are witnessing the edges of possibility, and with it, the edge of human understanding. Still, hints alone aren't proof. The path from possibility to certainty demands rigorous questioning. And that's exactly where astronomers now stand. Despite the tantalizing signals, scientists are urging patience. The signs of DMS are faint, barely above the background noise of deep space. There's a real chance that unknown atmospheric chemistry could mimic a biosignature without life being involved at all. Or that technical limitations in Webb's instruments could produce misleading patterns. In short, extraordinary claims demand extraordinary evidence. That's why astronomers are planning repeated observations, using multiple instruments and longer exposure times to cross-check the findings. They're also considering alternate explanations: chemical reactions deep within the planet's oceans, photochemical processes high in its atmosphere, or geological emissions unlike anything seen on Earth. Until the evidence becomes overwhelming, the scientific community remains cautious. Hopeful, yes, but grounded in rigor. Because confirming life on another world would be the greatest discovery in human history, and there is no room for error. Yet even amid all this caution, one thing is becoming increasingly clear. K2-18b may not be the exception. It could be the beginning of a whole new kind of world. K2-18b is now believed to be a Hycean planet, a world shrouded in thick hydrogen clouds with deep oceans potentially stretching for thousands of kilometers below. These planets are larger than Earth, more massive than Neptune, yet temperate enough to harbor liquid water. For decades, scientists thought life could only exist on small, rocky planets like ours. But if Hycean worlds can nurture life, the implications are staggering. They are far more common than Earth-like planets, and where there are oceans, warmth, and chemistry, life has a chance to emerge. If life can thrive beneath a crushing hydrogen sky, hidden in the depths of endless alien seas, then the universe could be teeming with worlds brimming with possibilities, hiding in plain sight. And so the question isn't just what K2-18b is hiding, it's whether we're finally ready to listen closely enough to hear it. Astronomers are already planning their next moves. James Webb will continue observing K2-18b, scanning for stronger, more definitive signs of DMS and other chemical markers. Meanwhile, new missions like the ELT, the Extremely Large Telescope, will join the hunt, offering even sharper eyes on distant worlds. This is just the beginning. K2-18b is the first, but it won't be the last. For the first time in history, we have the tools to glimpse the atmospheres of alien planets, to search for signs of breath, chemistry, and life itself. And if that faint whisper across the stars turns out to be real, it will mean we were never truly alone. Never truly alone.